Good morning, children. Today we are going to learn decimals. What is decimal? Let's take a number. 1, 2, 3.456. 123.456. So number which is having this point is known as decimal and this number is known as decimal number. Now how this decimal number been formed? They are formed from the fractions. So decimal and fraction, they both are interconnected. What is fraction? Fraction is a number which is having a numerator and a denominator. Okay. This number is known as a fraction. Such as if I say 2 upon 10. So 2 upon 10 is a fractional number. If I write it as 2 upon 100 or 2 upon 1000. These all three are the fractional numbers. Now we will form this decimal number with the help of the fractional numbers. So in this question, 1 0 is given at the lower end. So before one number we will put a decimal. We will start from the ones place. Okay. So before 2, how many zeros I will put, it doesn't change its value. It will remain 2 only. So because before one number I have to put a decimal, means before 2 I will put a decimal over here. So my answer will become 0.2. In the next situation, again I will put 3 zeros over here. So this will also not change the value of 2. So before 2 numbers I have to put a decimal now because it is 2 upon 100. 1, 2. So I will put my decimal over here. So the answer is 0.02. In the third situation, before 1, 2, 3, 3 zeros are given as the denominator. So before 3 numbers I have to just put my decimal. So 1, 2 and 3 means after these 3 numbers I'll put my decimal over here. So my answer will be 0.002. So like this we have formed the decimal numbers. We will take one more example. Suppose I have taken one question, 349 divided by 100. So here I have to put my decimal before these 2 numbers because 100 is given over here. So before 2 numbers when I'll put my decimal, this will become 3.49. Now suppose if in place of 100, 10 will be given, then I have to put my decimal before one number. Before one number means before 9, in between 4 and 9. So in this case my answer would be 334.9. Now we will learn how to convert these decimal numbers into the fractional numbers. So as I told you, when the denominator is given in the form of 10, 100 or 1000, we will just put our decimal equal to the number of zeros given in the denominator. Like before one number, before 2 numbers and before 3 numbers, in this case we'll put our decimal like this. Now when we have to convert the decimal number into the fractional number, what we have to do? We will take the same example. 0.2 is given over here. So for changing from the decimal to the fraction, when I remove this decimal, after the decimal, how many numbers will be given? That many zeros we will put after the 1. So here, when I will remove this decimal from here, after decimal, only one number is given, that is 2. So I will put 1 0 over here after the 1. This has become 2 upon 10. Or it can be written as 0.2. This is the decimal form and this is the fractional form. Now we will change this one. I will remove its decimal over here from here. Then after the 1, as 2 numbers are given, so I will put 2 zeros. So this has become 2 upon 100. In this case, when I remove decimal from here, after the decimal 1, 2, 3. 3 numbers are given, so after 1 I will put 3 zeros. So its fraction is 2 upon thousands. So here in the starting we have taken this number. So I will change this number into the fractional form as it is a decimal number. So I will remove its decimal from here. After the decimal as 3 numbers are given, so I will put 3 zeros after that. So it is become 1,23,456 divided by 1000. Okay. So this is the change from decimal term number to the fractional number and from the fractional number to the decimal number. That is 123.456. Now children, you have noticed that after the decimal, I am not reading the numbers altogether as I am reading these whole numbers. I said 123.456. So according to you, shouldn't I read this 456? No, there is a reason behind it. So let's understand the reason. I will explain you why after the decimal we are reading the numbers as individual. Why we are not reading them all together. So the reason is their place values. Okay, so let's see the place value chart. So children, here this is the place value chart. First of all, I will show you that suppose here this is the decimal. Okay. So the numbers before the decimal are the whole numbers as we were doing before. They will be read as ones, tens, hundreds, thousands, 10,000s and so on. Okay. These are the numbers before the decimal. The places after the decimal will become tenths, that is TENTHS. The word THS we are including over here. Tenths, hundreds and thousands. Here these numbers doesn't start from ones. After the decimal, the numbers are not starting from ones. Okay, so the places before the decimal will be normal, that is ones, tens, hundreds, thousand. After the decimal, they will become tens, hundreds and thousands. So let's take an example. Suppose here I am writing 4.56. So if I will tell 56, then 5 should be at ones place. But 5 is at tens place. That's why we cannot read this as 56. That's why we are reading it as 4.56. Let's take one more example. Suppose 2.3. Okay, so 2.345. Okay, so here I should read it as 2.345. But 3 is not at its hundreds place. 3 is at tens place, 4 is at hundreds place and 5 is at thousands place. Because children, why it is at tens place? Because this is 0.3. So if I will take it as 0.3, I will remove this decimal. That means it is become at its tens place. Okay children? How should I speak it? I should speak it as 3 tenths. I should read it as 3 tenths. Okay? So that's why I will read this number as 2.345. So the concept is clear that after the decimal we will not read the numbers all together. We will read them individually. So if this will be a number, that is 12.345. So this 12 will be read as a altogether number as it's a whole number. So on the basis of this, we can write their expanded form also. So we will take the same example, 4.56. So this can be written in the expanded form in two ways. How? This 4 is a whole number, so we will write 4 as it is, plus 0.5, 0.5 I can write, plus 6. So 5 is at tens place and 6 is at hundreds place. So when I will write 6, this has become 0.06 over here. Okay? As it was on hundreds place. Now I will write in another form that will become 4 plus. As it is at its 10th place. So I will write 5 upon 10. And here 6 is at hundreds place. So I will write 6 upon 100. So these are the two forms by which we can write it in expanded condition. I will take one more example, that is 234.509. Again I will write it in the two different forms. This has become ones, tens, hundreds. And these are become tens, hundreds and thousands. So I will read it as 200 plus 3 tens, that is 30, plus 4 ones, that is 4, plus 5 tens. So it will be written as 0.5 plus 0 hundreds, that is 0.00, plus 9 thousandths, that is 0.009. Or it can be written as 200 plus 30 plus 4 plus 5 upon 10 plus 0 upon 100 plus 9 upon thousands. So these are the two different forms of the expanded condition. Now from the expanded form, we can write it short form also. If I'll take this number itself, I will arrange it. 4 is a whole number. After 4, I put a decimal and I will write zeros, so that will not change the value. Then 0.5, decimal के नीचे decimal लिखना है हमें, and this has become 0.5. Then 0.06, so this has become 0.06. Always this condition you have to follow, that under the decimal has to come. Now I will add them. So 0 plus 6, 5.4. So I got 4.56. Here 4.56. So is this clear? How to squeeze the numbers from the expanded form and how to expand the numbers from its normal form. Now we are going to learn some terms related to decimals, that is equivalent decimals, like decimals and unlike decimals. So what is equivalent decimals? Equivalent decimals are the decimals that have the same value. So the decimals which are having the same value, they are known as equivalent decimals. So let's take an example. If I'll say 0.5 and 0.50 and 0.500. So as you can see, they're all having the value 0.5 itself. After the 5, how many zeros I am writing, that doesn't change its value. Because 0.5 means 5 upon 10. 0.50 means 50 upon 100, and 0.500 means 500 upon thousands. So when we convert into the lower terms, when we cut the 0 from 0, we get 5 upon 10. Here also we get 5 upon 10. That means in a series, when we are reading the numbers and we get all the same digits, then they are having the equivalent value. So they are called as an equivalent decimals. Let's take one more example. Suppose if I say is 12 upon 45, 12.45, 12.450 and 12.4500. So you can see when I am reading, so their all digits are at their places. Only the zeros are missing over here. So that will not change its value. So they all are equivalent. These three values are equivalent. But if I says 12.045, then you can see at the tens place, the value of 4 has been replaced by 0 over here. And at the hundreds place, value of 5 is replaced by 4. And at the thousands place, value of 0 is replaced by 5 over here. That means 12.045 is not equivalent. So the places of the decimals which are given at the tens, hundreds and thousands place and so on, that should not be changed. Their values should be same. Then they will be considered as an equivalent decimals. Clear, children? Now we come to the next concept, that is the like and unlike. What are the like fractions and what are unlike fractions? So, the fractions which are having the same number of decimal places means same number of decimal places. They are known as a like fractions. And the numbers which are not having the same number of decimal places, they comes into the category of unlike fractions. So look at this question itself. 0.5 having only one number after the decimal. 0.50 is having two numbers after the decimal, that is at tens and hundreds place. Whereas 0.500 is having three numbers after the decimal, that is tens, hundreds and thousands. So these all three numbers are having three different values. So they are coming into the category of like fractions. Unlike decimals, sorry. Okay, because they are not similar at their decimal places. If I'll put a 0 over here and I will make it equal to the last one and I will put one more 0 over here. So these all three values as the places of the decimal is become equal. That is tens, hundreds and thousands. So now they become like fractions from unlike fractions. To understand the like and unlike fraction, this is not necessary that when we are reading the digits, they will be having the same value. They can be having the different values also. Let's take one more example. Suppose I'll take 7.01, 18.34 and 2.6 and 9.459. These four are having the different values. That means they are not equivalent. This is clear. Now, after the decimal, this is having two numbers, one number and three numbers after the decimal. So they are unlike decimals. So when we are changing these unlike decimals into the like decimals, I have to just see that I will see the number which is having the maximum numbers after the decimal. So this is having the maximum numbers after the decimal. At tens place, hundreds place and the thousands place. So if I put a 0 over here at the remaining places, so these all are having now the places at tens, hundreds and thousands in equal number. So now they are having same number of decimal places. So now they all become like fractions from like decimals from unlike decimals. Now you understood how to convert the unlike decimals into the like decimal. Equivalent decimal which are having the same values while we are reading in the terms of their places also. Okay. Like and unlike decimals, when they are having same number of decimal places, they are like decimals. So, the equivalent decimals can be unlike because their places can be different. And this is not compulsory that like decimal has to be the equivalent also. Like decimal can be unequivalent also. Clear?